Lighthouse flagged a 400 KB jump in firstload.js across the entire app. The culprit, a single barrel file that made tree shaking impossible. The article focuses on the pages router but mentions the app router in passing. In the app router, pages is replaced by app with page, TSX, and layout, TSX. Additionally, the app router supports loading, TSX, error, TSX, and not found, TSX files for automatic loading and error states, which are not covered. Ensure your structure accounts for these new file conventions. The article mentions private folders prefixed with to prevent root exposure, but only in the context of the pages router. In the app router, private folders work the same way. Prefix a folder inside app with an underscore to exclude it from routing. This is useful for keeping utility components or data fetching logic out of the URL path. The article mentions root groups, e.g., marketing, but does not show a concrete example. Root groups allow you to organize routes without affecting the URL structure. Here's how to use them in the app router to group marketing pages under a common layout. Let's break down Next.js Project Structure, folder organization best practices, how it works, and the exact mistake behind that failure. In this video, we'll cover proven patterns for organizing Next.js applications, from solo projects to enterprise monorepos. You'll learn where to put files, how to use app router conventions effectively, and which patterns scale. Next.js Project Structure is the deliberate organization of files and folders to maximize maintainability, scalability, and developer efficiency. It matters because a chaotic structure leads to merge conflicts, slow onboarding, and hidden bugs. When you run npx create next app, you get a bare-bones structure. This is intentionally minimal, but for any real project, this flat layout quickly becomes unmanageable. You must extend it with a logical separation of concerns. Here's the command to create a new Next.js app with TypeScript, Tailwind, and EaseLint. The resulting structure is a starting point, not a production-ready architecture. The most common mistake is grouping files by type. Instead, organize by feature. For example, a user profile feature would have its own folder containing the component, styles, tests, hooks, and API calls. This makes it easy to locate all related code. Here's an example of a feature-first structure. Each feature has its own folder with subfolders for components, hooks, API, and types. Shared UI components live in shared/UI/. The pages directory should only contain root files that are thin wrappers. Each page file imports a feature component and passes props. Never put business logic directly in a page file. Here's a thin page file. It imports the dashboard page component and a data fetching function from the feature folder. The page itself has no UI logic, just routing. The shared folder contains code used across multiple features. Each shared UI component should be a self-contained folder with its component file, styles, tests, and an index, TS barrel export. Here's a reusable button component in shared/UI/. It accepts variant and size props and uses Tailwind classes. This component is generic and can be used across features. The lib folder holds pure functions, configuration, and third-party integrations. Examples include API client setup, database connection, and authentication helpers. Keep it framework agnostic. Here's an Axios client setup in lib/API/client, TS. It configures base URL, timeout, and interceptors for auth tokens and error handling. This is pure logic, not tied to any feature. The public folder is for static assets served directly by the web server. Do not put source code here. Organize by type, public images, public fonts. Use the tree command to see the structure of your public folder. Keep it shallow and organized. Next.js supports global CSS and CSS modules. Put global styles in styles/globals, CSS. For component-specific styles, co-locate the module, CSS file with the component. Here's a typical globals, CSS when using Tailwind. It includes Tailwind directives and custom base styles. Component styles should be co-located, not in this file. Shared types and interfaces go in the types folder at the root. Feature-specific types should live inside the feature folder. Export shared types from an index, TS barrel. Here's a shared types file for user and auth-related types. These are used across multiple features. Feature-specific types would go in the feature folder. Unit tests should be co-located with the component or function they test. Integration and end-to-end tests go in the tests folder at the root. This makes it obvious when a file lacks tests. Here's a unit test co-located with the login form component. It tests rendering and form submission. Keeping tests next to the source file makes it easy to see coverage. The config/ folder holds static configuration like site metadata and navigation links. Environment variables go in env local and are accessed via lib/constant/env/ts. Here's a site config file. It centralizes site metadata so you don't hardcode URLs or titles in components. Custom hooks shared across features go in a top-level hooks folder. Feature-specific hooks stay in the feature folder, always prefix with use. Here's a generic use Debugging hook in hooks. It's used across features and doesn't depend on any specific features types. Here's the final recommended structure. The key is consistency. Every team member should know where to put new code. Use a contributing MD to document it. This is the full production-ready structure. Start simple with just features, shared, and lib, then add folders as you grow. This is the same issue we highlighted at the start. Here's exactly why that happened. A barrel file component/index, TS re-exported every UI component. When a page imported button from that barrel, it pulled the entire module graph, and tree shaking couldn't prune it. Every page shipped the whole component library. A barrel file re-exporting every UI component caused every page to ship the entire component library. Tree shaking couldn't prune it because the barrel created a single entry that referenced everything. The fix is simple: import components directly from their source files. Instead of import button from @components, use import button from @components button. This allows tree shaking to work, reducing bundle size. This is the mistake that caused the 400 KB bloat. Using a barrel file that re-exports everything prevents tree shaking. Always import directly from the source file. To diagnose bundle size issues, use the Webpack Bundle Analyzer. Add an analyze script to your package, JSON. Also, set up Lighthouse CI to catch regressions. Let's run through some common interview questions. What is feature-first folder structure? Group files by feature, not type, for scalability. How to prevent barrel file bloat? Import directly from source files, not barrels. Where do you put shared UI components? In shared/UI/ as self-contained folders. And a few frequently asked questions. App router or pages router for new projects? App router for new projects. Principles apply to both. How to share code between features? Extract shared logic into shared or lib. Where do API roots go? In pages/API/ or app/API/ kept thin. Let's recap the key takeaways. Group code by feature, not type. Keep pages thin wrappers. Co-locate tests and styles. Avoid barrel files for UI libraries. Ready to go deeper? Up next, Next.js with Drizzle ORM, database integration guide, then Next.js with Shadkin/UI, component library quick start, then TurboPack optimization in Next.js 16, complete guide and React server components security, protecting RSC in Next.js. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.